Welcome to everybody and thank you for stay here following this webinar. My name is Alessandro Garnero, editorial manager of the magazine Electric Motor Engineering, and I would like to give a personal grateful to our partners that they will speak today. Special thanks to Professor Marco Villani from Università of l'Aquila, technical director of the magazine and chairman of this webinar. Now, Professor Villani, thank you, and the place is yours.
Thank you, Dr. Garnero. Good morning, everyone, and welcome to this technical webinar. It is known that the electric mobility represents a possible solution to the pollution and global warming problems. The impact of internal combustion engine on the environment has led to replace it by alternative propulsion systems, among which the electric machine has become the primary candidate. In the next 20 years, a third electric vehicle sale is expected, which should exceed that of traditional internal combustion engine cars. The new technologies for energy storage and powertrains play a critical role in the development of the electric vehicle market. Recent advantages of high-quality materials and power electronics have contributed to new energy efficiency and high-performance electric drives that use new electric motor technologies. There is a great interest in finding propulsion systems with high power density, and several types of electric machine have been proposed for the current electric vehicles. The strong demand of high-performance electric motor for automotive application requires the use of new design procedure, an accurate choice of the material for the insulation, new electrical steel for the stator and rotor cores, new winding typologies, adequate cooling system, innovative technological solution in order to satisfy the higher requirements and constraints in terms of encumbrance, weight, efficiency, reliability, and cost. This technical webinar will focus on these aspects, and I'd like to thank the speakers, EuroGroup, CAME, Demak, Meccanotecnica Umbra, and Bora, for their contributions. I'd like to thank all the attendees and also Tecniche Nuove for the arrangement of this webinar. During the webinar, you can submit questions by using the chat. Now we can start, and I invite the first speaker, Dr. Mario Villalon by EuroGroup. EuroGroup is a leader in the production of stator rotor cores for many automotive companies. The title of his presentation is Effect of Glue Bonding in Mechanical and Magnetic Properties of Electric Motor Cores. Please, Dr. Villalon.
Thank you, Dr. Villani. First of all, I would like to give my sincere thanks, recognition to Dr. Villani, who is very close to my company and has been always generous in offering spaces in which we can collaborate. Also to the magazine, Electric Motor Engineering, whom we collaborate and participate as often as we can. So I am the innovation director in EuroGroup. You will see today in 20 minutes 3 publications that we have worked in I tried to synthesize as much as I could to give you, let's say, a better image of the contribution my company is putting on the market in the context of the electrification of society. So without further ado, allow me to present the effects of glue bonding on the mechanical and magnetic properties of electric motor cores. In EuroGroup, we build the stators and rotors, not only for, let's say, the traction motor of EV applications, but also for industrial motors, house appliances, and all the market of electric motors. I will show you that we've been in the market for a very long time and that we have a global footprint. But since 2015, we have been called into the EV market. Now I'm putting some images that you can see with the insight that we found last year. We developed this small video to show our customers and our allies that the demand for the electrification of society is much higher than whatever the production is today of electrical steel and also of stamping rotors and stators for electrical machines. What I mean is that today there is not enough capability on the planet to supply the amount of electrical machines that is demanded by our society. We are working very close with electrical mills, trying to orient, trying to define what are the best business cases, how to invest, how to create this capability. And we are working also very close with the customer, the OEMs that are producing these electric motors. Not only in the car sector, also industrial sector and house appliances. But today we're going to focus on the electrical vehicle. And as you can see, in EuroGroup, we have many companies as Eurotranciatura, Corrada, SAF, aluminum die-cast, and many sister companies, and we are all oriented towards building the best electrical machines for the whole vehicle, the whole car. We have the secondary motors of all the car, fan, window, seats, any servo motor that you have in the car, we build it. But also we have specialized in very recent years in the traction motor that has some special features, as it has to be especially efficient and high power and reliability also. So here you have how our company grew since 1967, and you see in red since 2015 how the electrical vehicle sector has increased our let's say activity very much. We are placed everywhere. We started the electrical vehicle venture especially in Mexico because of a special company in California that I'm not allowed to mention by contract, but for whom we build all their motors globally. So this global footprint is very important for American, European, and some Asians customers today that we have. We, let's say, supply more than 60% of the traction motors in North America, more than 50% of traction motors in Europe. In Asia, the things are much more complicated. We have a Chinese facility, but you know that the market over there is especially structured in such a way that we are positioning ourselves slowly, but in a positive manner, rapidly, I would say. That is going to grow rapidly from now on. So let me tell you today about this story. This is a virtuous cycle, I call it, because in 2014 we were given the exclusive property of a technology that is very kind, that allows you to glue bond electric laminations without heat at room temperature in less than 2 minutes, meaning that you can use it in a very fast mass production way. This is what is needed by our OEMs. In 2016, we launched the first products for this American company I mentioned you before, and then in 2019, we started working with most of our customers, Ford, General Motors, Volkswagen, all our major customers we have today. Today we're continuing opening new applications in the EV sector with new customers and tier one who works with some other OEMs. So I would like to focus now on the most technical side and leave, let's say, the commercial side and behind. So we have published short communications in 2020 and 2022 that I would like to share with you. In this slide, I am also showing a number of patents that we have filed behind the most efficient ways to produce in a mass production setting traction motors for electrical vehicles. So I'm going to show another video here where you see a very different plant that has to be very clean, because now we're speaking about glue bonding inside of the press. In the same stage where you cut the laminations to produce the stator and the rotor, we are capable of glue bonding those laminations together by adding a primer on top of the lamination that will come into contact later with some glue dots that we will apply below the lamination. So now the lamination has glue dots strategically placed where you want to have adhesive strength, and they come into contact in the last cutting stage, and then because it is an anaerobic process, the curing will start. That is a very fast curing. As I said, below 2 minutes, you reach sufficient or enough adhesive strength for the part to be taken by a robot and sent into the inspection line and packaging station. We've studied this product with our customers, OEMs and tier ones, and we have demonstrated these benefits that you see and that I'm going to show a little bit further in the following slides. But this product is obviously the most efficient magnetically and mechanically. You can see the products coming out. These are real products. After 2 minutes in the press, they're ready to be shipped. The robots are going to take them and send them into inspection. We also have laboratories that are going to perform a batch, let's say, quality inspection that is required by our customers. All the information is gathered into the cloud. So our facility is Industry 4.0, and our customers can follow our production even through cameras, and they can look at their production in line. We have, well, my laboratories that we have set up in Mexico and in Italy with these special test benches that we have developed that are capable of measuring some very tiny differences that sometimes are not sensed by commercial test benches, although we also use commercial test benches, let's say, in addition to these one. The typical result that we like to show, it is on your left side in red, you have a typical interlocked and welded core that we call it conventional core. And the same lamination was glue bonded on the right side in green. And then you can see that the energy losses that are shown in this graph are very much reduced. We are speaking about, in this example, 44% less losses. That means a great amount of less heat, a great amount of less vibration and noise. We have also developed methods to obtain the Bertotti coefficients with the use of Steinmetz equations. So this is a picture of myself on the right side of the picture with Mr. Giorgio Bertotti, and on the left side you see our CEO for the automotive industry, who is also an innovation expert and doctor degree. These are the test benches that we have set up complementary to the electromagnetic test benches we have that can measure noise, both in a free setup or measure noise directly within the electromagnetic experiment. And we've been testing in the publication I showed, the short communication we've sent to RINA, that is the World Metallurgy and Magnetism Convention conferences. So we've compared many things, the effect of interlocking, the effect of welding, the effect of cleating, and all this compares with glue bonding. And you can see from those publications in red the conventional fastening methods, and in blue on the right side how glue bonding benefits by decreasing the amount of losses. These losses comes basically by the damage that is made by these conventional methods on the special alloys that are produced by our steel mills. And this is very important to be understood because the steel mills invest a great amount of carbon footprint in producing a very sophisticated alloy, and then our message is try not to damage that special lamination because we have invested so much carbon footprint in it. So let's avoid breaking, making holes in it, welding it, let's say overheating it. As you can see, the metallographic images, these materials break like glass, and once they're broken, their magnetic efficiency is very much diminished. So that is the rationale behind it. But when you continue studying the effect of glue bonding, you can show that the stiffness, the mechanical stiffness under compression, as we replicate the shrink-fitting effect inside of the motor housing, the stiffness is much better with glue bonding, and the energy losses, even under compression, was shown to be much better when using a glue bonded product. So these are all results that you will be able to find in the communications that I mentioned before. This is a typical vibration test in a free setup with the hammer technique, and you can see on the left side that you have three modes of vibration that are shown with the product that was welded and annealed. And once you take the same product and you glue bond it, removing the weld cords and removing the annealing for the matter, you see how the vibration disappears very much, like it is reduced more than 20 times. You still have the same mode of vibration because it is the same geometry, but the amplitude of the vibration and also the sharpness of the vibration is very much reduced. We are capable of relating these, let's say, vibroacoustic behavior with the welding, also with the annealing that will damage the welding that already damaged the lamination and the special alloys that I mentioned before. So what we're saying in these articles is it is beneficial to go glue bonding, and we presented a rationale where glue bonding allowed to reduce eddy currents, and I'm going to jump fast on these because eddy currents were shown to produce the vibration that I mentioned before. But because I see that I only have a couple of minutes remaining, I'm going to jump to the last study that I wanted to show you. This is a study that shows on top the BH curve. BH curve is the magnetization curve. So you have, for a given amount of current, a magnetic density that is called magnetization. It is measured in Tesla. On the left side in red, you see the magnetization curve is very soft, is very slow. The slope is small. In green, you have a much bigger slope, and you can see that with less current, you produced a higher magnetization, meaning that with less current, you produce more torque in your car. And that is very important because current is heat, current is also vibration, current is management of your battery, and current is management in your inverter. And with the University of Padova, we analyzed further in a driving cycle the behavior of using less current in your machine and what it would represent in terms of the losses, in this case, on the overall machine, including the battery management and including the inverter. And now we're speaking about an improvement of 10% of the energetics of your car. So not only on the motor, I'm speaking about the overall machine, and this is reflected in a range improvement of more than 10%, meaning that for the same battery charge that you're going to with your car, you're going to drive more than 10% longer with it. And that is very impressive. This is the report by the University of Padova. The University of Torino help us to make sense of these numbers, and they show that it represented a value of 15,000 euros in benefits for a longer life of the car, battery and inverter system at the customer level. So now I have my little chrono here. It looks like I've been speaking for 20 minutes, and that was the deal. Dr. Villani, I will give you the microphone back. Thank you.
Okay. Thank you, Dr. Villalon, for your interesting presentation. We have received 2 questions by the audience. The first one is, what is the typical quantity of electrical steel needed for a permanent magnet synchronous motor magnet? I think it depends on the motor size, but what is your comment?
Well, in my experience with our customer, we are speaking of motors going from 150 to 250 kilowatts. And they weigh from 20 to 30 kilograms. So that's the amount of steel you have in there.
Okay, another question from the audience. Do you think that in the future the stator and rotor core can be realized by 3D manufacturing?
I love this question because as a belief, I have that belief, and I am very excited by this. But I have to confess that my boss is not very happy with my belief, and I agree with you. The future is probably yes, additive manufacturing. Thank you.
Okay, another question. Why are the application limit benefits to glue bonding technologies?
Well, as I shown, the benefit is to control vibration and to use the maximum, let's say, magnetic property of your material. The limit is when you have some special application at those temperatures that are not compatible with organic chemistry. Because, now your cores are composite materials, and they're made with organic, let's say, compounds, and they are limited by, let's say, I would say your application should not exceed 200 degrees, basically. So sometimes we expect some motors to work harder than that, and that would be, let's say, the state of the art where we're trying to improve these composite materials for special applications.
Okay, thank you again for your contribution. Thank you, Dr.
Thank you, Doctor.
Villalon. And now we move from the stator and rotor core to the stator winding. And I invite the next speaker, Dr. Fabrizio Bardelli by Came. Good morning.
Good morning.
The title of his presentation is Electric Motors Winding Solution. Please, Dr. Bardelli.
Good morning, and first thank you, Mr. Villani, and thanks to Tecniche Nuove for this opportunity of taking part to this webinar. We will give you our contribution to this event with our point of view. It is the point of view of a manufacturer of windings and winded stators. We are actually the one who is using, for instance, Eurotranciatura stator cores. Before I should speak about winding solution, I would like to spend a few minutes of a presentation of Kame. Kame is well known on the market, but probably is not so well known to all participants of this webinar. Some figures about our company is a company of more than 45 years old. Last year we closed with a turnover over 130 million euros. More than 360 employees in the company. We serve 17 different countries. We have 6 plants. All these plants are located in the same valley. We are in the northeast, located in the northeast of Italy. And regarding numbers, products, we produce every year around 5 million windings, which means a capacity of more than 20,000 windings a day, and 8 million die castings, aluminum die castings parts, which means 35,000 die casting parts every year. You probably will find our winded stators in a lot of different applications. You can find it in pumps, you can find it in electric motors, generally speaking. You can find it in gear motors, air compressors, doors opening, high pressure water cleaners, and as well as traction and automotive field. This is just a short map of our 6 plants. As I said you before, they are located in the same valley. We are the northeast. It's about 40 minutes from Verona. And this is just a picture of our headquarters. So, our mission. I will not read the whole text, but there are 2 keywords in this page, and I would like to highlight them. The 2 keywords are innovation and solution. Innovations of equipments, production lines, devices, and not only of product, but also training with consultants on different topics. It means a constant and continuous improvement of all processes. The second word, it is solutions. Solutions to the needs of the customers. It happens not rarely, so sometimes that the customer has not completely defined the project. It is more likely a sketch. Kame is able to give its contribution and support to define the project and to find the best solution, thanks to the knowledge and experience of many years. A short view of the product range, which is on the top, winded stators. Particularly, we are speaking of distributed winded stators, which are very, very common. The second picture is concentrated stators, particularly for brushless motors. Concentrated means in this page that we are speaking about coils winding around each tooth. The third picture is a view of the die casting division. So we produce parts for electric motors, but not only for electric motors. And the picture on the bottom is just as to complete the production process is the machining of the winded stators with the housing and as well as including the rotor eventually with the shaft. As I said you before, not only aluminum parts for electric motors, but also for as third parts die casting, so very different from electric motor parts such as housings, shields, and flanges. And here you can have just a view as an example of some of the most important production of Kame, speaking of aluminum die casting. Not only products, I'm just speaking briefly about services. Myself, as R&D manager, about different topics such as the design of the electrical motors, the test of electrical motors, One important thing nowadays is the optimization of existing motors. We can see a lot of improvement we can introduce in electric motors, and as well as some bench tests of electric motors and partial discharge. And regarding of the die casting division, it is we can follow the customer with the project from the very beginning, and we have also the possibility of making some optimization and simulation with magma, for instance, and we follow the project from the very beginning, from the production of the mold and then the wall test. Just a brief picture of my colleagues. And now we are just going to the point of the discussion, which is the winding solutions with advantages and disadvantages. In this picture, I just decided for two most important for Kame solutions. On the left, you will find a typical distributed winded stator. This one is specifically for a forklift application. On the right, you will find a concentrated winded stator, which is basically for traction for automotive. There are some keywords on this page, which are, for instance, cost, feasibility, capacity, also the sustainability and recycling. And on the right, in regarding of the product and the process efficiency, power density, materials, and processes. Before I should go in deep into some details, I would like to show you a brief video. So I ask the organization to start this video, please. So just our reference if you want to contact us for a further request. Then I would like to go back to the presentation, to the page, and I will go in some details about these two different solutions. As I said you before, on the left, you will find a typical distributed winding stator. On the right, a concentrated one. If I would focus only on as well efficiency level, on power density, so dimension of the stator and weight of the stator, for sure the winner of this match will be the brushless stators, so the concentrated stator on the right. But there are on the table not only these key points, there are many key points. There are the material cost and material feasibility. If I look into the distributed winding, for sure it is a very, very well-known process. We can find all the needed parts very, very easy. There are many different suppliers for the same part, as well as for instant Eurotranciatura. On the contrary, for the brushless stators, there is so far not yet a commercial part. Every product is a customized product. For every product, you need a dedicated stamping tool, you need a dedicated winding tool, and so on. Also, speaking about rare earths and magnets, it could be also some constraints, some trouble to find the right material at the right price. Just to give you a comparison, a very, very rough comparison between a standard motor with a distributed solution and the casted rotor, and comparing with a brushless motor with a rotor with magnets, for sure, you think about reducing by half the weight and the dimension of the motor, but the cost will be 2 times, just to give you a very, very rough indication. So cost has to be taken in account in the design of the motor from the very beginning, for sure. Feasibility, it's related to the process. Looking into the distributed windings, it is, as I said, it is a very, very known, common process, so very easy, I could say, to produce. We cannot say the same so far for the concentrated stator. Sometimes it's very challenging to go to the industrialization of this kind of stator. Capacity is also a very important key point. The capacity of the distributed stators is much higher compared to the concentrated one, if I'm also focusing on the flexibility of the production line. If I think for sure of a very, very dedicated, customized production lines, it's not an issue. But generally speaking, the distributed winding is more successful in terms of numbers. And also, we should think about sustainability and recycling of the parts. Again, the winding status is the distributed winding status is, I would say, this is the winner compared to the concentrated one. Just a short view of this concentrated. This is for instant on the left. You will find some solutions for e-bike or for steering on the left, e-bike in the middle, and for traction and automotive on the right. Design and testing is one of the also the very, very important key point in these products, meaning that motor CAD designing of the motors is nowadays a must. Interesting is that by motor CAD, by this simulation, it is possible to go in not only in one unique and defined solution. It is possible to find different solutions. So we see sometimes the possibility to offer to the customer at least 2 different solutions, again, stating all the different points, the key points, and as well as the cost level and the price at the end. And not only design, but also the bench test to confirm the results of the design. At the and just to the end of the presentation, I would like to spend a few minutes on partial discharges. It is partial discharge, it is an issue related to the inverter duty. Anytime you have an inverter supply to the electrical motor, you will face troubles because of peaks of volts, which will at least disturb the motor, but in the worst case, they can really damage the insulation of the winding stator. And the higher the bus voltage, the worse is the condition. We are getting recently some requests from our customers for 800 volts electric motors. And 800 volts means that you will face for sure strong troubles in regarding of partial discharge due to these peaks of volts that are related to the inverter function itself. They cannot be avoided, but it is possible to work on that and to find the best solution in terms of partial discharge to ensure and grant the life of the electrical motor during its function. Now it's the final question: if I go back to the picture of these two status, who is the winner between these two different solutions? And actually, I didn't speak about other solutions which are on the market as well, the hairpin or the flat copper wire. Only these two ones, because these two ones are property of KAME processes and knowledge. Who is the winner is not an easy question. And the answer, I would say, that it is not that easy again. And probably if I look into the most important automotive players, I cannot see so far a unique choice for that. We can see both choices, also different choices, also matching with rotor with magnets or reluctance rotors and so on. So a unique solution so far is not yet been defined. And in my opinion, next year we will probably define the best solution in terms of product. And all producers have to be ready for the new challenges. And I would say, and that to the end of my presentation, that KAME is ready for that. Thank you very much.
Thank you. Thank you, Dr. Bardelli, for your presentation. I have a short question for you. How much is the maximum slot fill factor for the distributed winding in your product?
Good question. It depends on the size as well, because if we go to the smaller stator that we produce, which is the IC50, or speaking of dimension, we are speaking of a 73 outside OD, 38 ED stator. We are around 32-33%. If I look into an industrialization, so into a feasibility. The filling factor is considering the total cross-section of the stator slot and the cross-section of the wall copper wire, not including the insulation. So on the smallest one, we are around 32-33%. But if I go to the bigger stators, bigger sizes, so the IC 160 and 180, and particularly for low voltage stators, which are produced with many parallel copper wires, we are going up to 48%, which is extremely high, but granting a very high quality result.
Okay, we have received several questions from the audience. The first one: what are the cooling solution thermal management within the stator, especially for e-cars?
Oh, this is a better question for motors producers. But anyway, it is for sure. So far, we know from our customers is the using the housing with some channels and have a water cooling system. This is what we know so far, as well as also the cooling of the shaft, which is another good solution to keep temperature in the limit. But probably you, Professor Villani, could also better answer than me to this question.
Yes, but we have also a presentation by Meccanotecnica Hungary for this point. Another question is, there are any production solution about PCB winding, especially for axial flux permanent magnet motor? Because this axial flux motor could be a valid alternative for in-wheel motor. Do you use this technology, this kind of winding?
Not yet. Not yet. We are more experienced in radial flux brushless stators. We know very well as well this technology and this solution. We have one project on the table that we probably will open this year, and it is quite challenging because the production process of an axial flux stator is quite complicated, much more complicated compared to the radial flux solution.
Yes, yes, because you must ride flat winding is more difficult.
Exactly.
Another
Exactly,
question:
Mr.
what
Villani.
about another question from the audience? What about hairpin winding?
Good question. As I said in my presentation, hairpin winding is not yet a property of camera processes. The main reason of that is that typically this process is owned by the final customer. So every electric motor producers will probably produce itself this kind of stator. We know the technology is very, very dedicated, is very, very customized to the stator shape, which means that forget the flexibility that you have so far with the distributed winding solution, but also with the concentrated ones, because in this case, all the production line is and the related toolings are completely linked to the stator core shape. So it is a very, very challenging production process.
Yes.
The filling
Yes.
factor is extremely high as well, but
yes. Last question for the future. Do you think that printing the winding will be really in the next future? Printing winding. Some
we got
company, I
some.
know,
Yeah,
like
me too, Mr. Villani. It is. We got some so far some rumors, and we are just waiting for some more details about this solution, which would be really a big challenge for everybody, because it should completely change the whole process chain from the very starting. As I said, it is so far we got some rumors. We are taking care on that as well, but I cannot say that there are any kind of running project in Kame or with our main customer.
okay. Thank you again, Dr. Bardelli.
Thank you.
And thank you. And I invite the next speakers, Dr. Pietro Colombotto and Alberto Menozzi by Demak Group. Good morning. His presentation concerned the insulation of electrical machine. The insulation represents a very critical point for the electric motor. And the title of their contribution is Electric Motor Spotting with High Performance Racing Systems. Please.
Morning, everybody. Thank you, Dr. Villani, for the introduction, and thank you to Tecnica Nuove for the opportunity of being here. I will start the presentation with some words about Demak Group. Okay, Demak Group is a quite unique company in this field since it has a double soul, a chemical and a mechanical soul. As you can see from this picture, we are more or less spread around the globe. The two main manufacturing plants are both in Torino. So Demak SRL is focusing the manufacturing on dispensing machine solution, while Demak Polymers on resin system formulation. And then we have several branches around the world from many years, like in North America and South America, just born last year in Germany, in Essen, and then India, China, to give a nationalized product to our customers and to give technical support to our already established customers and potential future. Some numbers about Demak Group is more than 40 years of experience in the dispensing field. Consider that the chemical company born in 1976, while Demak as machine manufacturer in 1984. There are two production plants, as we already said, and we have installed several equipment worldwide since we also follow many different application fields, like not only electrical insulation and potting of electronic devices, but also foam gasketing, LED encapsulation, and many others. And especially in this period, we have developed several new resin systems that e-mobility customers are requiring basically every day. And our group is, of course, largely used to export. Consider that the national turnover represents more or less the 10% of the overall Demak Group turnover. These are some of the main applications that we face every day on the market with our customers. So, of course, capacitor spotting, battery potting, or also with gap filler solutions, transformer door handles, PCB, many different applications. Of course, today we will focus a little bit more into the electric motor potting and solutions that we can provide. So the core Demak value and let me say the biggest value that we can try to transfer every time in all our customer project is exactly this combination of the mechanical and the chemical background that usually permits us to provide a 360-degree solution to our customers, starting from the case study of the electric motor to perform tests in our laboratories, to select the best resin system according to the parameters that our customers are looking for, and then engineer the dispensing solution according to the parameters that we have discovered together with our customers in our laboratory. And so deliver to our customer a complete package made of resin system, dispensing solution, and a transfer of know-how on the process. This is just an overview on our equipment manufacturing area that today is also in quite good expansion. It can count already on 10,000 square meters, only fully dedicated to machines manufacturing. Being an Italian company, of course, we are more than welcome to customize dispensing solution. Of course, we have our standards, mostly referred to smaller and compact units, but when we are talking about fully automatic line of production for the motor potting, of course, it is always a custom machine. And then Demak, of course, owns some patented technologies along the different dispensing fields that we follow. Just a couple of examples. In this specific picture, you see a small and compact unit, largely used for laboratories or for small production batches. In any case, in every machine that Demak manufactures, there's always the heart, that is our continuous vacuum technology for the correct treatment of resins and hardeners. So in this picture, you can notice in the background metering and mixing dispensing unit, and then on the same bench a vacuum chamber to perform vacuum potting. That is absolutely necessary when you want to get a very high impregnation grade of the stator or the rotor when you perform potting in those machines. And it can have, of course, a quite small and compact footprint compared to fully automatic line. So fully automatic line is a solution where Demak is taking care at 360 degrees of the potting process for stators or for rotors. So starting from the preheating of the parts, of course, the preheating also depends on the temperatures involved in the process and at the temperature of the resin to which will be dispensed. After preheating of the stators, vacuum potting, and then resin polymerization through tunnel ovens, and to arrive at the final stage of the cooling down. So this kind of automatic lines usually work with one operator only that has just the duty to load and unload the parts from pallets. In the case you want to automatize also this step, of course, the machine can work autonomously without any operator. Also, some words regarding our resin manufacturing facility. Here the process of production is fully automatic. The company today is in expansion, so Demak will invest very soon in a new plant in order to increase the production capacity that already today can count on 50 tons per day, working on 3 shifts. Thanks to the fully automatization of our cycle, of course, it's also possible to guarantee a complete lot traceability. So we always know from A to Z what happens to each resin and hardener batch. These are the 3 main families of product that we formulate and manufacture. So room temperature curing epoxies, heat curing epoxies, so the combination between epoxy and anhydrides, and polyurethanes. Of course, each different family find the correct application according to the piece that we have to encapsulate. In electric motor is largely used epoxy system, while, for example, for PCBs or delicate electronics is more common to use flexible material like polyurethanes. So every time, of course, we choose the correct resin system according to the project that we are facing. Being a chemical company, of course, it relies a lot on laboratories. There are 2 laboratories in our facility. One is dedicated to the R&D and production quality control. Let me say that in this moment we are investing a lot into R&D because, of course, in mobility, as for the other colleagues here that speak into the webinar, is requiring new systems, is requiring new technologies every day. And so, of course, also Demak is investing a lot in new formulations studying. And then there is a second laboratory where we perform all the tests to determine the physical characteristic of the resin system. So parameters like thermal conductivity, dielectric strength, all the useful data that you can find on the technical data sheet of a resin system. This is a quite broad overview on the properties on which we focus mainly when we formulate a new resin system. So for sure, to guarantee good chemical and humidity resistance to the resin system, very low viscosity to get a very high impregnation grade of the stator or the rotor while we are potting, and many others are also high temperature resistance, thermal shocks. Let me say that many of these characteristics are also always paying attention to our mechanical background. because, for example, we perfectly understand how tricky it can be to handle abrasive materials in production, or also the impregnation grade through a low viscosity. So many of these characteristics are also coming from our mechanical experience of the dispensing technology. The company is ISO 9001 certified, and we are also going through the IATF certification that will be operative and certificated from January 2024. This is made to, of course, serve better our tier 1 and OEMs customers. And we cooperate a lot also with external laboratories, with University of Torino, Milan, for all the tests that we are not able to conduct maybe internally. Of course, we cooperate a lot with others that have the instrument adapted for the scope. So going a little bit more into the specific topic, Demak can, since it's not only a resin system manufacturer, it's not only a dispensing equipment producer, it can really be a partner, a consultant for electric motor customer and people that would like to perform potting technologies into their models. So we have, let me say, three kind of approach with our customer. One is process consulting, so where we go to determine the best potting cycle with all the times for the productivity and the impregnation of the stator. We can make, of course, a chemical consulting, going to select the best resin system according to the parameters that our customer are looking for along our quite broad portfolio of resins. And also piece and tooling design consulting is very common in these days. Let me say that many of our customers have the motor that is designed for trickling technology or for dipping technologies. And of course, so this motor generation doesn't consider the potting material inside. And so Demak can make a first intervention, engineering the correct tooling to perform potting anyway, despite the not correct shape, let me say, but also work with our customer R&D to work on the next motor generation in order to be already designed to receive potting material inside. Many of our customers are also, as I've heard from previous presentation, are also looking for higher voltages, like 800 volts, even 1200 volts. And so the current, let me say, technologies are having some problems. Specifically in trickling, you can have a quite poor heat dissipation, since the material thickness on top of the winding is such low that it doesn't permit it to dissipate so much the heat generated during working operation. Sometimes you can have also partial discharge problems in terms of a poor insulation, if you are not able to fill all spaces and to replace the air into the system. You can have some problems into vibration and noise, since thanks to potting technology, it's also possible to really strengthen the mechanical features of the motor and to avoid some vibration problems. And also you have a slightly lower protection from external agents. You can, for example, think about in-wheel motors that are exposed to external agents like vibration, bumps, water, dust. All these problems can really affect the motor. And so that's why Demak is proposing potting technology. To go deeper into the resin selection, I will leave the floor to my colleague, Dr. Menozzi, that will explain you better the characteristic of the resin system we are going to propose and the process related to the selection. Thank you, Dr. Menozzi.
Thank you. I am Alberto Menozzi. I am the plant manager of the chemical plant of the group. Our R&D is very strong in this field, and we have developed several formulation, epoxy and polyurethane, room temperature and heat curing, in order to meet all possible customer requests and possibly also to anticipate some customer requests. As a main characteristic of the system that we look for is the low viscosity and good impregnation. Is a very important characteristic because it's necessary to fill completely the space, avoiding to leave air inside. Air has practically no heat conductivity, is 0.03 watt meter Kelvin, so nothing. It's very important to avoid air and to have by resin a very good heat dissipation. Reducing the space of the motor means to increase the power density, means to increase the develop of heating. It's important how we can dissipate this heat in the better way. So here you see some parameters that we look that are, as I say, low viscosity, also lowest possible specific gravity, important for the car, for example. Totally reactive system, no volatile inside. Low shrinkage and good adhesion to the part. High thermal conductivity, as I say, in order to dissipate as much as possible the heat developed by motor. In the meantime, high thermal shocks resistance, because it's very important when we have a quick passage from cold to warm condition to not to have cracking. It is a parameter that is related a lot to low coefficient of thermal expansion. That must be lowest possible. For the resin must be near of the coefficient of expansion of the metal of the winding. Flame retardancy, that is also important for the safety of the car. And other parameters that are however important, like high thermal class, high thermal resistance of the resin, chemical and water resistance. For example, we think about the on-wheel motor that need to resist also in immersion of water, and elasticity and resiliency of the mass. Here there are some of our system at higher performance. We have three systems here. The first one is an heat curable system, anhydride base, that show a very high thermal conductivity, 2.2. The second one is heat, but not so high temperature curing system. Very interesting. We will return back on this system later. Also, this system show a very good heat resistance and very good heat dissipation, and it is very easy to use. The third one is a room temperature curing system, more generally used, but having, however, a good thermal dissipation until 1.4. In this slide, we show one system that is suggested for rotors. In this case, the main important point is the glass transition temperature. That must be very high, because rotors can arrive to high temperature, and is necessary to have the resin that mechanically maintain the characteristic also at a high temperature. Please note that all these systems are UL certified. These three systems are more used for mass production. Mass production means a lot of motors to produce, are more easy to like working, Two of them are heat curable, so needs oven for curing. The third one is a room temperature curing system that, however, show a very high thermal shock resistance and a very good 1.2 thermal dissipation. So it's used a lot and by customer for mass production. In this graph, we summarize the different system that we have presented, showing the glass transition temperature versus thermal conductivity. We have a quite wide range of system for the different application: room temperature curing, heat curing, and also some system that is in the middle. That means that require only lower temperature for curing and a shorter time. As I said, we focus now on a particular system named XE663 and DK50-11. This is a system that show a lot of good features. First of all, the low viscosity, very important for application and wetting of the motor, of the wires of the motor. High thermal dissipation, high operating temperature, very high thermal shock resistance, incredibly how much cycle it resists, resistant to chemical, for example, ATF oil, excellent electrical insulation, and very easy to use and without the need of high temperature for curing. Here you see the weight loss after 5,000 hours at 200 degrees. That is reduced loss of weight, maintaining practically the same starting mechanical and electrical properties. We focus the attention on thermal shock. We have performed a thermal shock between -40 up to 163 degrees, so a very high jump of temperature, more than 200 degrees, with a passage between the cold and warm condition, less than 30 seconds. We speak about 10, 15 seconds more. And thermal permanence at low and high temperature of 60 minutes. You see the metallic nut that we use for this test, that is totally immersed in resin and give a good starting point for the possible cracks, having sharp angles and having this thermal expansion of metal respect to the resin. The results are incredible. Not only arrive to 100 cycle, that is the minimum that we ask for the system, but we arrive to 1,000 cycle without any crack, and we stop at 1,000 because we need to use our chamber for other tests. Here you see the mixture viscosity at 60 degrees that remain very low for a good long time, sufficient to wet perfectly the wire. You see a section of the wire that no air is present between the different windings. So it's very important that the resin without air can show the maximum heat dissipation that can show. Another interesting system use also for motor, also at room temperature curing, is the XE661 and the K5006. In this case, the thermal, the TG is lower. We speak about 65, 70 degree. But also tests performed on motor show that operating temperature is reduced between 25 to 40% according to the motor dimension. It means a lot of more life for the motor in working, in exercise.
Okay, so thank you, Dr. Menozzi, for the precise insight. As you can understand, the main target to achieve a very good impregnation and a good heat dissipation can not only depend on the resin system itself, but is a combination of factors. So, first of all, the state or characteristic, the spaces available, the shape, the dimension, and the weight that we have to respect. After that, of course, a good selection of the correct epoxy resin system to have good performances that our customer is looking for. But the third, and maybe one of the most important, is also the dispensing solution that has to perform the potting in a certain way in order to achieve the results that then are showed on the technical data sheet. Thank you, everybody, for your attention.
Thank you.
Thank you, Dr. Colombotto and Menozzi, for your presentation. We have received some questions from the audience. The first one, can the component be received? If yes, how?
I would like to explain one thing. We speak about thermosetting resin. Thermosetting means not thermoplastic. Usually, when we speak of recycling of plastic, we speak always of thermoplastic. In this case, it is impossible to use thermoplastic because the resistance to heat is too high to use common thermoplastic that can melt or weather and soften at that temperature. So the product are thermosetting. They cure in totally and arrive to a final TG that is the characteristic of the polymer. The possible recycling in this case is only to burn the motor. It doesn't contain chlorine, so there is no corrosive or toxic smoke arriving from burning, but it is not possible to return to the original material.
Okay. The next question, from a cycle time point of view, is the potting more difficult to integrate in a process than trickling? From a cycle time point of view.
For sure, trickling technology is a quite fast technology. Nobody can say the opposite. What I can tell you is that with a fully automatic line, we have also achieved a takt time of 2 minutes per motor, and we are talking about a huge motor dimension. What is not possible to be achieved chemically, it's possible to be achieved mechanically. So with a correct manufacturing machine configuration, you can also overcome some limits that are imposed from the chemical part. So, for example, curing times that are longer or dispensing cycle that is longer compared to trickling. So, with a good combination of the right choice of the resin system, and be with short curing time and a quite productive machine, you can achieve really good takt times.
Okay. The last question from the audience. Do you use nanomaterials to have more high thermal conductivity?
We know that exist some nanomaterial, nano additive to improve the characteristic, some characteristic of the encapsulation resin. In this moment are, however, extremely expensive. We need to consider always a balance between the technical characteristic of the product that must be at the best as possible, but also a reasonable price. So nanomaterial we have used for prototype in some case are not so easy to use without changing properties in manufacturing, but however is possible to use. But in the normal standard production, the use of nanomaterial in this moment is not still in use.
Okay, we've received another question. Please, a quick answer. This question is, in general, how much is the cost of the motor winding increased by introducing an encapsulation process? Quick
But
answer.
let me say that of course it depends on the motor dimension and the quantity of resin that you dispense inside. There are resin system going from the mass productive one that are cost efficient, like 4 or 5 euro maximum per kilogram, up to of course resin system with high performances that can even reach 20 euro per kilogram. So for sure the selection of the resin system and the quantity of material that you put inside, we have to calculate together what can be the impact. In any case, we have formulated a resin system with very cost-efficient factor that can, of course, reduce this cost increase.
Okay, thank you again for your presentation. And we started this webinar with the starter rotor course, then starter winding, insulation. Now we move to the cooling of powertrain, and I invite the next speaker, Dr. Alessandro Ventura. Good morning, by Meccanotecnica Umbra. The title of his contribution is Mechanical Phase Cells for a Mobility, E-Axle, Gearbox, and a Pump. Please, Dr. Ventura. Microphone.
Sorry, first mistake. First, we are happy to have this opportunity, and we thank you, Tecninove, Professor Villani, for this invite. Few words about Meccanotecnica Umbra. Meccanotecnica Umbra is a company that produces mechanical phase seal. The mechanical phase seal is the product between a rotating shaft and a fixed case where a fluid must be limited inside. Meccanotecnica Umbra is present in the world with the production plant and support directly the customer in China, India, Sweden, Turkey, USA, and Brazil. Today, we produce mechanical seal for several applications. The typical application for a mechanical seal could be a water pump, and where is present a water pump, like an automotive application, a dishwashing machine, industrial pump, and so on. There is the opportunity to use a mechanical seal for avoiding the leakage, for limited the fluid in the circuit, in the cooling circuit, in case of automotive or in any other circuit that contain a fluid. Today we speak about the application for e-mobility, the product we developed for e-mobility. In this area, we have we developed the 3 different type of products. A group of product is devoted to the water pump with a dry rotor. In this case, the goal of this kind of application is to have a long life service and a long life service. The other 2 products are developed for traction motor of electrical vehicle. In this case, we have 2 different products. One is for cooling the rotor shaft, and the other one is to separate the transmission to the electrical motor, because inside the transmission there is an oil to lubricate the transmission, and in almost of a case these 2 rooms must be separated. The requirements for this kind of application is a quite long life service that is typical 8,000 hours, and a very, very high speed, that this application can reach speed up to 25 or also 30,000 RPM. The product that we developed are shown here in this slide. On the left, there are the products that we use for water pumps, electrical water pump, starting from shaft 4 up to shaft 12. On the left, on the right, there are the products developed for e-axle motor. We developed during these last years 3 different type solution for cooling the rotor, and 1 product for oil separation between electrical motor and the transmission. In particular, we will focus this presentation on the product for cooling of a motor, and the product we are considering is the layout B. So we, after developing 3 different layouts, we see that the best solution is the layout B, for the reason I will explain later. The cooling of the shaft of the electrical motor is something like this. So the mechanical seal has the role to avoid the leakage between the rotary shaft and the cover of the motor. We have seen doing experience with our test bench that we produce inside, that the best solution in this case is to design a mechanical seal with a very small peripheral speed. This means that the shaft of the motor, where the mechanical seal is placed, must be small. With this solution, we are able to avoid or reduce much the leakage due to the centrifugal effect, because in this case the fluid is inside the mechanical seal. So during the rotation at a very, very high speed, the centrifugal force on the fluid between the sliding phase of mechanical seal increase the leakage rate. So to reduce this effect, it is important to have a design of the shaft in the seal chamber smaller as possible. About the oil mechanical seal, we have different needs, because we have the oil outside the mechanical phase seal. And this means that there is no centrifugal effect that increase the leakage. Let me jump to the next one. So the solution that we developed for cooling the rotor shaft is this kind of layout. As I told you before, we required a very small shaft, but we obtain in this case also a very small axial length. The main characteristic of this mechanical seal is that we found a system for assembling the seal and avoiding this type of error, so the tilting effect. So when a rotary part of the mechanical seal is assembled on the shaft, the mistake between the rotation axis of shaft and the rotation axis of rotary part could form an angle. This angle produces a tilting effect. This tilting effect increases the leakage. We developed a solution in this product to avoid that this mistake during the assembling affect the leakage rate. We verify the performance of this type of seal in specific test benches that we produce, as I told you before, inside. This is some picture of our test bench. Sorry. In this test bench, we are able to collect the leakage in form of vapor and liquid. We are also able to reproduce the axial movement of the shaft of the motor. And we are able to verify and measure the power consumption due to the mechanical seal. This is another important aspect of the power consumption, because the sealing system represents a power consumption for the system of the motor. As you know, all power inside the battery must be devoted to the movement of the car. So we have to avoid to lose this power with other systems, like, for example, the sealing system. What we obtain in terms of friction and power consumption is shown in this curve. So we are able to run the mechanical seal in a different condition of the fluid temperature, speed, pressure, load, and we can also define some surface characteristics to have the best compromise between the power consumption and the leakage rate. We also test the mechanical seal in different temperature, also the low temperature. And we also tested the mechanical seal for fatigue endurance test. I would like to come back to this slide to show you that the power consumption related to this sealing system change depending from the pressure of the fluid and depending also from the temperature. So if the temperature increases, the power consumption is reduced. If the pressure increases, the power consumption is increased also. The value of the typical value that we have, the range of the power consumption that we have in the test we carried out is something between 120 watt to 250 watt. It's not small, but we will see how it's possible to reduce this amount of power consumption. So about the performance in the endurance test, the main goal was to understand the leakage rate of this sealing system. We reproduce the working condition in terms of speed, and we define a speed profile in terms of axial movement of the shaft, in terms also of the pressure of the system. So at the end, we, using the experience with our customer and making a summary of the needs of the sealing system, we define an MTU cycle for this kind of endurance test. We are able, with this cycle, to reproduce in 1,000 hours an amount of 63,000 kilometers. The result of the leakage rate in this test for 4,000 RPM, for 4,000 hours, and this means 1 million of kilometers for the vehicle, is something like this. So we reach a leakage, a total leakage in terms of liquid of a couple of cc. We produce an amount of vapor around 25, 26, 27 cc. So the total amount of leakage in 4,000 hours, that means 1 million of kilometers, is 33, 34 cc. This leakage must be managed during the life of the motor. We also try to find a solution to reduce the power consumption of this sealing system. One solution for obtaining the result is to design some particular geometry on the face of the mechanical seal. In this case, we apply a pattern of dots, and working on the density of these dots, we define an optimum percentage of dots where the power consumption is used in a range of 65 to 168 watts. Of course, this is not for free, because at this reduction of power consumption, the leakage rate increased. These are the curves, but we can summarize. Sorry, we can summarize the result in this picture. So we have in 1,100 hours, so 4 times lower than the other test, an amount of leakage very similar to the other test. So this means that we have around 4 times the leakage with this kind of solution. What means in terms of managing of leakage? So if we place the leakage we obtain in a plastic glass, we can see that a full plastic glass is more or less 190 cc. The leakage we obtained in 4,000 hours with the first solution is something like this. So we have 33 cc in 1 million of kilometers. This amount of leakage, that is the sum between liquid leakage and condensed vapor, must be managed inside the electrical motor. It's not a big quantity, but it's a quantity that must be considered during the design of the sealing area of the electrical motor. If we want to reduce the power consumption, we have to pay this with an increased leakage. This leakage is as I told you before, more than the previous test, and in any case, this increase is not something dramatic. Is in any case something that can be managed in the lifetime of the electrical motor. So now we pass to the oil seal. Between the transmission and the electrical motor, it could be the need to separate these two rooms. We design an oil seal, mechanical fail seal, and doing this, we try to have similar dimension of an oil lip seal. We obtain this result, and the difference between the cooling mechanical fail seal and is that we was able, thanks to the fact that the oil is outside the mechanical seal and not inside, to use a technology used for example, in the transmission for helicopters. This kind of solution allows to reduce the friction to zero at high speed. This is an example of a mechanical seal for helicopter transmission, and this is the graphics where it's possible to see the friction of the mechanical seal when the speed increases. This type of geometry are called grooves and has the role to separate the face and avoid any contact between the two faces. So avoiding the contact, we reduce the friction close to zero. We apply this technology to an oil seal for electrical motors. We also tested this solution in our test benches. We are able to measure the torque using a floating chamber. So in this case, we perform the measure in static condition instead of dynamic condition. And we add, sorry, it's 20 minutes. So we simulate in this test bench 3 different lubrication: full lubrication, splash lubrication, and fog lubrication. This is an important difference because what we obtained in the 3 different lubrication situation are different. So we have the same behavior of the helicopter's transmission mechanical seal. So at high speed, the friction is very, very low. The difference is that if we increase in full lubrication and splash lubrication the pressure, the capability of the mechanical seal to fly is not so evident. But if we works in a fog lubrication condition, we are able to reproduce exactly the same condition. So we have at high speed a friction close to zero. In addition, we can see that the power consumption in a splash and full lubrication is around 40 watts at every speed. In fog lubrication, we don't exceed 20 watts, and when we increase the speed, this amount of power consumption decrease much, close to zero when we stay over 20,000 RPM. So at the end, we can say that in case there is the need to cool the rotor, the mechanical seal the mechanical fail seal solution is a good solution because especially for the lifetime. The use of, in case of oil mechanical fail seal, the using of fog lubrication is useful for having a very, very low power consumption for the system. Finish.
Thank you, Dr. Ventura, for your interesting presentation. I have a short question for you. What is the weak point of the structure design, if any?
So the structure design is a big opportunity to reduce the friction. Unfortunately, this solution is applicable only when the fluid is outside. If we apply the structure when the fluid is inside, we produce a leakage that an amount of leakage that is bigger. So there is always an optimization situation between the power consumption and the leakage rate.
Okay. Thank you again for your presentation, Dr. Ventura. And I invite the next speaker, Dr. Cristiano Bora by Bora Company. Good morning.
Morning.
The title of his contribution is The Challenges of Automotive Electrification for Two-Tier Suppliers. Please, Dr. Bora.
Thank you. Thank you, Mr. Villani, and good morning, everybody. My name is Cristiano Bora, and I am the Chief Executive Officer of Bora Company. Today, I would like to talk about the challenges of automotive electrification for second-tier supplier like our company. First of all, I would like to spend a few words about our company and our history in order to give you an overview of how we develop our products that will help us to understand which are the main challenges of electrification for us. Our company was established in 1975. So we have more than 45 years of experience and tradition in metal stamping. We started as a tooling manufacturer, and then afterwards, in the 80s, we started the serial production of components for home appliances and automotive industry. In 2006, we extended our production footprint and we established a plant in Poland. And today, with our know-how and the implementation of new technology, we can also offer to our customer co-design analysis, feasibility studies, and prototyping. As I mentioned, we have two production plants, one in Italy and one in Poland. We are certified ISO 9001, IATF 6090-49, ISO 14000, ISO 45000, and we recently achieved also the certifications for information security, the TISAX certification, and the ISO 27001. Few numbers about us. Our R&D department has the computer-aided design, the computer-aided manufacturing, and two finite element method analysis workstation. Our tooling facility is based in Italy, and the production plants, as I said, are in Italy and in Poland for stamping. In Italy, we can process materials till 10 millimeters, in Poland till 3-4 millimeters. We can also perform assembling, welding, and of course, tooling, maintenances, and modification. We have more than 17,000 square meters of covered surface of our plants. And to give you an idea of our capacity, we process in 2022 20,000 tons of raw material and produce more than 50 million pieces to our customers. Our automotive portfolio, as you can see, is made of different components for different applications. As you can imagine, some of these components will disappear with the electrification. Some of them will remain but will change their characteristics. And some of these components are completely new, I mean, that are completely dedicated to the electric vehicles. In our R&D department, as I said before, is involved in the development of the products together with our customers, because it is needed and it is very important today, the co-design phase with the customer to develop the products. With the simulation of the stamping process, we can simulate and know in advance. In advance means before the tooling manufacturing, which will be the final results of the stamping process in terms, for example, of material thickness or spring back, or, for example, the tensile stress at the end of the stamping process. Our developing process is, first of all, as I said, the feasibility studies and the simulation of the components. As you can see in the video, you can see the simulation stamping process running, and the colors that you see represents can represent different parameters, for example, the final thickness or the spring back or the tensile stress at the end. We also use in this first phase of development additive manufacturing to study other characteristics of the final products before having the prototypes in sheet metal. The second phase is the tool design and validation. Of course, the tool design is performed with the 3D computer-aided design modeling. That is, of course, a standard. But what is important today to have a better process and reduce the lead time is to implement this design, this 3D design with new technology. For example, after the tool design, during the tooling assembly, we check with technologies like augmented reality that the final assembly is in line with the 3D design.
Bellissimo.
I mean that in this case, the operator that is responsible for the assembly of the tool is able to check, comparing the 3D model with the real image, the real tool that is under assembly, is able to check and see if there is some error or there is something missing in the assembly that is going to be performed in this phase. Last phase of the product development after the tool assembly, of course, is the product validation. The product validation means that we need to certify that the product is compliant with the drawing. With the drawing means with the dimensional specifications and other requirements. The standard systems used to check this and perform this validation are, for example, 3D measuring CMM machines, or, for example, laser and optical scanners to check the component geometry. This brief overview was to let you understand which is our development process of products and stamped components. because now I would like to speak with you about the challenges of electrification, because electrification, of course, is changing a lot the design of the vehicles and also the components inside the vehicles. These new kind of vehicles, of course, brings new products that before were never developed, new materials to be used in the stamping process, in our case, and new requirements in terms of products validation. I mean, in the past, the main validation process was the measuring of the part to check that the geometry was in line with the drawings and in line with the tolerances. Today, we have other requirements, other specification to be checked during the product validation. Our R&D and quality department, of course, are focused on these new challenges in order to assure to our customer quality and reliability of production process. When I talk about new products, for example, there are electrical control unit, housing and covers, because of course in electric vehicles there is a huge quantity of electrical control units that for us, for a stamping supplier like us, bring new challenges in terms of materials and specification. For example, for this kind of covers and housing, aluminum and zinc coated materials are used for heating transmission and corrosion resistant capacity. The simulation of the stamping process is critical because we are using new materials. It means that the stamping and the formability is not like the standard materials that we used in the past for the stamping, and also because for this kind of products the cracks are not allowed, and because we need to assure that there is no cracks to avoid the humidity penetration inside the control units. So for the simulation is important for our R&D department to set new parameters for the simulation, because of course the reliability of simulation is also based on the parameters that we used in the simulation of the stamping process. And the simulation of the stamping process is the first crucial step that we need to run before doing any other step in the development of a new process, and of course because before giving to our customer the feasibility of the component that is asking to us. A second challenge, as I said, is new materials. New materials is not only related, for example, with aluminum, that is a material that is very common for the new applications, but we are also using high strength steel for the new applications. The high strength steels help to increase the fatigue resistance of the components, guarantee high rigidity, and reduce the weight. The reduction of the weight is very important for the electric vehicles. So our customers are developing products with high strength steels in order to reduce the final weight of our components and of course of the vehicles. If we talk about stamp, so stamping process of a material that has a high strength, it means that the formability is worse, is not so good if compared to the other materials that we used in the past. It means that the simulation, the FEM analysis is very crucial to be sure that the stamping process and the stamping method that we are developing is reliable for a serial production for million pieces, and also is important to reduce the time to market. And also in this case, the simulation parameters are very important to have a reliable simulation and a reliable stamping method before beginning the tooling manufacturing. Also, the product validation is changing a lot. As I mentioned before, in the past, the main validation process was the measuring of the final part. I mean, if the dimensions, the geometry was in line with the drawing and with the tolerances in the drawing. Today, with electrical control units, we have a lot of our specification that we need to check to validate the process and the product. For example, for covers and housing, since they need to protect the electric components, there are requirements that are very strict about, for example, the cleanliness for metallic and non-metallic fibers. So it means that we need to have new tests, perform new tests at the end of the production process to validate and to check the cleanliness. That was not so important in the past for mechanical components. Adhesion test is another very important test on the surface, because a clean surface is needed also to have a perfect sealing and isolation. And finally, also the leakage test is performed. I mean that, as I mentioned before, the cracks are very critical in this kind of components, but also the not visible cracks can be critical, because the leakage test is performed with air. It means that also very small cracks that are not visible can be critical for this kind of components. So it is needed also a leakage test to check that there are no cracks in the stamped parts at the end of the stamping process. As you can imagine, when you produce 1 million pieces per year, these kind of tests are crucial, and it's important also to find the good compromise between performing the test and, of course, offer a good and competitive price to our customer. Summarizing, I would say that electrification for a supplier like Bora, that is a second-tier supplier, means investments in training people, because, of course, we are talking, as I said, about new products, new materials, new technologies, and new tests. Investment in new technologies, and the collaboration and partnership with the customers is very important during the development phase, because the products are new, and the co-design phase is crucial to reduce the time to market, because with new products or new materials, we cannot be always sure that that product is suitable for a good serial production process. And also the sharing of know-how about the new specification and the new requirements is very important for our customers and for us as well. So at the end, I think that in order to assure a good transition to this new era is needed a deep change in the supply chain and in suppliers like us. And of course, the support and collaboration with our customer is crucial to follow this completely new road. My presentation is finished. Thank you for your attention. And of course, if you have any question, I am here available.
Thank you, Dr. Bora, for your contribution.
You're welcome.
I have two short questions for you. The first one is how transition to electrification changed the development process of product?
The development changed a lot, because in the past, let me say, the standard components that we were used to produce, basically at the end, we received from our customers the specification, the design of the components, and our customer was sure that that product was feasible, because it was well known. The characteristics, the tolerances, and everything was well known. And so basically there was no significant co-design phase. Today, the co-design phase is crucial, and before any release of any new product by our customers, they get in touch with us before the release of the product to study together and be sure that from a stamping and production point of view, this product will be feasible and reliable 100%.
Okay, the next question is how application new material impacted in time to market of new components?
I should say that time to market is not a problem, but nevertheless, it's a problem. I mean, that when you develop a new material and you need to use a new material for the stamping process, there could be some impact in the lead time. For this reason, the simulation, the virtual simulation with definite element method analysis is crucial, because if you need to run more loops of simulation, it means to spend maybe 5, 6, 7 days more during the development or the feasibility study. Of course, if you manufacture the tools and then you start the production and you discover that the stamping is not reliable, then you will lost weeks, not days. So the lead time could increase a little bit, but with the new technology, I would say that we are talking about days of increased lead time.
Okay, thank you again, Dr. Bora. With this speech, we have concluded this webinar. I thank again all the speakers, EuroGroup, Came, Demak, Meccanotecnica, Umbra, and Bora, the attendees, and Tecniche Nuove for this webinar. We have listened very interesting contribution. We got to know the new technological solution for automotive application. Mobility is a very topical issue for the next years, and the companies will have an excellent opportunity to invest in the production on innovative powertrains. In this context, the contribution of the universities will be important and strategic, in my opinion, and the companies can start fruitful collaborations concerning the design of motor and drives, batteries, cooling and insulation system, in the search of highly efficient and competitive products. With this comment, I conclude the webinar. Thank you again and see you in the next webinar. Bye.